The floor is yours.
Okay. Thank you very much, Job. Hello, my name is Jan Zorz. I come from Slovenia. I work for Internet Society. And I'm glad to be here. So this is now, as Paula said, another half an hour of Slavic English now. I hope you will understand what I'm talking about. Okay, first of all, let's get this out of the way. Acknowledgement, thanks to Internet Society, that lets me spend some of my working time in Go6 lab. So I'm also the CEO of Go6 Institute from Slovenia, that I worked before joining ISOC. And part of Go6 Institute is also Go6 lab, where we were testing IPv6 protocol scenarios and all this stuff. But now, lately, IPv6 is, people is deploying it, it's easy, it's no challenge anymore. So I got a bit bored in my lab, so I decided to look into this weird thing called DNSSEC. And since we are in Netherlands, there is no point in interest of time, I will just skip DNSSEC implementation slides because you are probably the best country in DNSSEC. So who here is doing DNSSEC on their domains? Okay, so those who lifted your hand, help the others that did not lift their hands with doing DNSSEC, and we are done with it, okay? Because it's quite easy, right? All right. So I got it all up and running. I actually used the Open DNSSEC platform, and thank you to Benno and to NLNet Labs to taking care of this project. It's brilliant. That was quite easy. And I'm also using Unbound and Bind for the DNS resolvers. And then when I got it all working, I became bored in my lab. So I was like thinking, okay, what can I do with this DNSSEC now? Everything works. DS records are published. The sky did not fall. Now what? Then I said, okay, let's have a look into this DANE thingy. What does it do? So as part of my job, I work in a do team, and we are taking care of this Deploy 360 portal, and we write about DANE. And I said, okay, why should we just write about it? Why don't we try it? Why don't we implement it and start using it? Okay, so what were the requirements? Okay, the requirements is DNSSEC signed domains, and the other requirement was, because I figured out that web servers, browsers are not supporting DANE yet. I decided to do it for email. Why? Because it's not, for web it's a bit easier. For email, it's a bit unexplored area. But what is the requirement? The requirement is Postfix server with TLS support, and the version must be higher than 2.11. Because before 2.11, there is no DANE implementation in it. And I think Victor Duchovny is the main character in this field that is implementing this stuff. But of course, I decided for Postfix 3.0.1. That was in early alpha stage at that time. Why? Just because I can. And because, because. Okay. So, what is DANE? Who here understands what DANE is? Okay. For those who did not lift the hand, ask your neighbor. No, sorry. Okay. DANE is basically a TLSA, right? So, and here is how, for example, do you see it? No, because it's off. See, this is the TLSA record for my public-facing mail server. It's mx.go6lab.si, and it's basically underscore 25. That's a port. That's a protocol. That's a host, and then this is selector. Basically, that means some stuff you can You can read more about DANE here, what this means. So this is basically, or is it a hash or a public key fingerprint of the certificate, or what is it, and how to handle it. And this is basically the fingerprint of the TLS self-signed certificate that is on my mail server. Okay. So in brief, how does the whole thing work? You start with SMTP session. This one gets start TLS, and it sends back a TLS certificate. Then you ask your DNS server, is there a TLSA record for this mail server? And this DNS server asks, this DNS server, is there a TLSA? So next one, when you get a TLSA, you do the DNSSEC validation. That's the most important part. You need to believe the TLSA. And then this one, when he receives the TLSA, it just sees both hashes of the certificate that he got from the mail server and the TLSA record that he got from the DNS. And if they both match, then this means that this guy is actually who we think he is. And we can establish a session and send an email. Okay, then I set it up. It worked, no problems. But then I was sort of like, okay, how can I test this stuff now? Okay, I did an internal setup, and I was sending emails between two servers in the same room, but this is not fun. So I figured out that, for example, there is a service provider, the internet service provider in my country, that they're following. We have friends that they're following what I'm doing in the lab, and they try to keep up with the experiments that I'm doing, and also they are sort of like, they are also trying this stuff out. And it's called T2. And actually they set it up, and then I was able to send email to their server and figure out if verification is working. I also sent an email to Benno and said, look, can you go in your logs, because I know you implemented DANE, can you go in your logs and see if it was verified or not? So then Benno sent me this copy-paste from their server, and then I was convinced that the whole thing works in both ways. Okay, if you want to do this stuff, this is the Postfix config that you need to put in. This is basically it. It's quite easy, right? So then I got bored again. So okay, DANE is working. It was not hard. It's just basically a TLSA and some testing. Now what? And I thought, okay, we got these T2 guys that implemented DANE. We got NLNet labs that implemented DANE that I know of. But am I alone on the internet using this stuff? So I did a little test. And I downloaded, I was thinking about where to get the source of the information of who else is on the internet, where the big guys are. And I downloaded the top 1 million Alexa domains. And I built a script. It's basically a bash script with a little bit of Perl. Sander will now start laughing. But I'm not a programmer. I'm a bash scripter. I'm a professional bash scripter. I don't know how to program. But I managed to do this stuff. So basically, I sent 1 million emails to sort of like test-DNSSEC-DANE at each domain, and then parse the postfix logs. After some tweaking and few tries, the script started working, and we got some good results. And the results is, okay, you might be a bit surprised. So out of 1 million domains, most of them had the MX record. And surprise, surprise, nearly 70% of all attempted SMTP sessions were encrypted. how cool is that? 70% of all sessions was encrypted of any kind of encryption method. Verified, anonymous, trusted, untrusted, whichever. But the important thing is that it was encrypted. NSA guys would not like this result. Okay, majority of TLS connections, 60%, were established with a trusted certificate. So actually, people paid money to have a certificate. Huh? Yeah, well, no, well, let's encrypt came a little bit later. Okay. This is not the. Okay, more results. So the connections that were established with TLS, anonymous 109,000, untrusted 167,000, trusted 410,000, and verified 128,000. What does it mean, verified? It means DANE Verified. Yippee! So out of 1 million sessions, I'm not alone on the internet. Yay! People is using DANE. Well, 128 of them. But anyway, you know. All right. So this is much higher number than I ever expected. I expected 2, and both of them I knew. But okay. Okay, so mail distribution. Okay, Google.com, they are getting a lot of domains. SecureServer.net, QQ.com, Yandex, emailserver.com, Zoho Mail, Lollipop, Condor Server, Gandhi, all this stuff. Some of them are using trusted certificates, some of them are not using TLS, some of them are using self-signed or anonymous certificates and things like this. But the problem is that none of top 10 the biggest servers on the internet, email servers, are not DNSSEC signed. Their domains are not DNSSEC signed. What does that mean? No DANE for them. Okay, until January this year. But at that point in time, that means no DANE. Okay, then I got these results, and then I got bored again in my life. I was like, okay, what can I do now? Okay, let's push a little bit DANE further to the far end of capabilities and see if it breaks. That's what we do. Okay, so I on purpose created the Malformed TLSA record and just changed one character in the hash. And of course, Postfix failed to verify it and refused to send a message. So actually, it did not send a message. And that is a good thing. That's a good behavior. Next one. Okay, so I said, okay, let's try with a mix of signed domains and non-signed domains, because as we saw in the previous experiment, those big servers are not DNSSEC signed. So if you are a client and if you point your MX record to the Google Mail server and you do TLSA in your zone and your zone is signed, what happens? Is this 1 million people now sort of like unable to do DANE because they are sending emails to these big guys? Let's see what happens. So now it's getting a bit complicated here, so bear with me. Example, Go6lab zone is signed, so it's mx.go6lab.si, right? It's obvious. So there is a TLSA for mx.go6lab.si also signed, and domain signed.si, that's just as an example, is signed, and mx points to mx.go6lab.si. So both domain of the sort of client is signed and points to my signed mail server. The other case is domain is not -signed.si, is not signed, and the mx is pointing to my signed A and quad A record of mx.go6lab.si. What happens if we send email to Jan at signed.si and Jan at not signed.si? What do you think it should happen? Okay? So, of course, when I send the email to jan@signed.domain, verified TLS connection, DANE works. But when I send email to jan@notsigned, DANE process did not even start to verify. Why? Because it got the MX record from the domain that is not signed, and it said, I don't believe this. So the DANE process actually exited, but the mail server delivered that email anyway. Okay, so this raised the big alarm in my head, sort of like, what the hell? From operational point of view, this is sort of like, what the hell? That means that if my mail server is at Google that is not DNSSEC signed, or somebody else that points to a signed domain, that will not work. Operationally, this doesn't make much sense. Maybe academically, yes, but operationally it doesn't make sense. Okay, then I tested the way that I put actually point the MX record from signed domain to the A-quad-A record in non-signed domain. So for example, if I would point to mail.google.com, that is not signed. And of course, when I send email to jan@signed.si that is pointing to non-signed mail server, then verification is not even started. And you know, it's just, the whole thing just breaks. I got lots of discussion about this stuff with Wes Hardaker and Victor Duchovny, actually. And all of a sudden, I got an email from Victor saying, Jan, look, and there is postfix improvement. He actually coded in that you can configure that you can enable DANE policies when an MX host has a secure TLSA DNS record, even if the MX DNS records was obtained with insecure lookups. So, yay, fixed. Now you can do all sorts of magic, because the point is that you can verify the endpoint. It doesn't matter where you got the routing information, the MX information. If you can verify that the endpoint is actually the endpoint that you are trying to send email to, why not verifying it? If you exit the DANE process and not verify it and send email anyway, this is not helping you. This is not helping anyone. So let's use the opportunity to verify things where we can verify them. So we don't know if that is the right place to send an email, but at least we know that that place is what they claim to be. Okay, then I got bored again. And then Let's Encrypt came around. And as the Internet Society is sponsoring Let's Encrypt, I said, let's test this stuff, right? And I got the access to the early beta program. And then I said, okay, let's put some certificates. I mingled around with all this stuff and got it working. And I said, okay, let's see how I can cover the signed certificate with DANE, with TLSA. So you can be double make sure that the destination is really the destination. So it's signed certificate plus verifying it through TLSA record. And here is the point where things gets interesting. Because if you do this, by default, the underlying key is changed when renewing. So what you usually do with Let's Encrypt, what I do, I set the renewal every first day in the month and just set up the process and renew and be done with it. But then, if you publish 311 TLSA, that means a lot of work, because the underlying key changes, the hash changes, your public key fingerprint changes, and that's a problem, because then if you have 1,000 domains that renew every month, that means that you need to put in your DNS server 1,000 new TLSA records and delete the old ones. That just doesn't scale. Well, you can automate it, but it doesn't, there's no point in it. So you could use 211 method that is actually verifying sort of like a key, a signing certificate. But there is a problem because by default in Let's Encrypt client does not include the DST Root CA X3 certificate. So first of all, I tried the method with fetching the DST Root CA X3 certificate, add it to fullchain.pem file, and verify that it did not change from last time. Because if it would change, then I would have to change the 211 TLSA record. So, and there is, I told you, I'm a bash scripter. This is a thing how I fetch with links the DST root certificate and actually add it to, parse it and add it to the PEM file. Yeah, I'm sorry. I'm sorry that I have to show you this horror. But that's the result. It works. If you test it with the online tool that verifies your TLSA records and mail, I got both. So here it should be green color. I don't know what's happening with this projector. But both TLSA records are usable. So one is verifying the root certificate and one is verifying my certificate. Okay, at next certificate renewal, by default, then the 311 TLSA record would not work anymore. So, because I'm a bit lazy and I don't want to change TLSAs every month, I figured out how to actually not change the underlying key every month. And I figured out that Let's Encrypt Auto and now the new one, the certbot -auto, has the CSR option. So there is a directory examples in the client where you have this generate csr.sh file where you can create your underlying key. That's basically it. And then you can use the same key every time you renew the certificate. So now I'm actually doing that. About the rotation of the underlying key, I will rotate it when I decide that it's time to rotate the underlying key. And that's the time when I will also change the TLSA record, but not automatically. This is a human-driven process. And of course, we still add the DST Root CA X3 certificate to the PEM file. So we have two different TLSA records that can verify that I am who I am. And this is, again, the result. After the renewal, everything works. Here's more reading. I documented the whole process for Deploy 360 portal. And it's easy. Those of you who are not doing it should start doing it. So we will not be alone in the world doing it. And that's it from me.